After learning about the order and degree of a differential equation, and after that the geometrical interpretation of the differential equation, here I will talk about how to use the separation of variables method to find out a solution of a differential equation. So not all differential equation can be solvable. So in this video we will discuss about how to use the separation of variable for those particular problems which can be solved. So in the last video I discussed about how we can use the separation method to write this equation in this form: dy equals to fx into dx. So this derivative form can be written in this differential form. Okay. So let us now come to the examples. What we are going to do in case of separation of variables method, we have a equation like this, and we are going to separate those. Suppose we have this equation here, and we are going to separate this in this form: divided by gy equals to dx. And next we are going to multiply this term with dy. So dy equals to fx dx. So we can see that with dy there is the term dx, with dy there is the term gy, and with dx there is the term fx. So we have successfully separated the variables x and y. Now we can differentiate to find out the solution of the differential equation. Coming to the first problem, we have this equation. So obviously we can take dy as a single term, and we can take this dx with this term, and after that we can use the integration. So this can be written as dy equals to 1 minus cos x divided by 1 plus cos x dx. Next, integration can be used. So this term here, we are going to use the formula of submultiple angle. By using the formula of submultiple angle, we can write 2 sine square x by 2 divided by 2 cos square x by 2 dx. 2 can be cancelled out, and it will give tan square x by 2 dx. Now the formula of tan square, the integration formula of tan square is unknown. So we can use this. It will give sec square x by 2 minus 1 dx. And in the left hand side we have this. So we can integrate this. It will give y equals to this term here, sec square. The integration of sec square is 10, and there is a half multiplied with x, so it will get divided. So we have 2 tan x by 2, and the integration of dx will give minus x plus c. So this is the solution of the differential equation, this. And as we can see, this is the first order differential equation and also first degree. So we have a one parameter family of curve. Let us now move to this example here, 1 plus x square. So again, if we write it in this form, 1 plus x square dy equals to x plus tan inverse x, and we can multiply here dx. So by moving this term here in the denominator, we can again separate the variables x and y. So it will give dy equals to x plus tan inverse x 1 plus x square dx. So again we can write it in this form: x 1 plus x square dx plus tan inverse x 1 plus x square dx. Now we can integrate this here and here. For the first term, we can use 1 plus x square u, and after that we are going to use the substitution method of integration. So it will give two x dx equals to du. Therefore, we will have x dx equals to half du. And from this side, we can see that the derivative of tan inverse x, which is 1 plus x square, is present here. So we can again use the substitution. We use the substitution method when there is a derivative of a term which is also present in the uh, in the integration. So we can take it like this, and it will give dx divided by 1 plus x square equals to dv. Okay. So by substituting these in these two integrations, we will obtain, here we have integration dy equals to, so here x dx means half du, and this term here is u, so it will give half du divided by u plus, okay, so there was a 2 here, there's a 2 here, so there should be a 2 here. So 2 integration, again tan inverse x means tan inverse x, this tan inverse x is v, so we can write here v, and 1 plus x square, 1 by 1 plus x square means dv. So here we have v dv. So we can easily integrate this. We will obtain half ln u plus v square plus c. So y equals to ln root u v square plus c. So by putting the values of u and v, we will obtain y equals to ln root over 1 plus x square, and there is v square, which will give tan inverse x whole square plus c. Now let us see this example here. Okay, so it can be separated easily. Dx sine 4x cos 4x. So separation part is quite easy, but the integration part is a bit harder. So what we can do here, we can divide the denominator and numerator by cos power 4x. It will give sec power 4x divided by tan power 4x plus 1 dx. Now we can do sec square x into, so we can write this sec power 4x as sec square x into sec square x, and one of the sec square x will give 1 plus tan square x divided by 1 plus tan power 4x dx. So the derivative of tan, which is sec square, is present in this integration. So we can take the substitution. So we can use u. Therefore, sec square x dx equals to du. Therefore, the integration will take the form like this: dy equals to 1 plus u power u square 1 plus u power 4 du. And there is an integration sign. Okay, so here again we can divide the numerator and the denominator by u square, and it will give integration dy equals to 1 plus 1 by u square 1 by u square du. Now this term here, it can be modified, and we can write it as 1 by u square divided by u minus 1 by u. So there is u square, there is 1 by u square, and there is a minus 2 term. So to cancel out that, we need to use a plus 2. Okay, so it can be noted that the derivative of this u minus 1 by u is 1 plus 1 by u square. So we can again substitute this function. So u minus 1 by u equals to z. Okay, so previously there is another substitution, tan x equals to u, and after that there is another substitution, which is this one, u minus 1 by u equals to z. So this integration will take this form: dy equals to dz. I'm writing dz because the derivative of u is 1, and the derivative of minus 1 by u is plus 1 by u square. Therefore, 1 plus 1 by u square into du, it will give the dz. So therefore, this dz term, and it will be divided by z square plus 2. So this integration can be done easily. It will give y equals to, so let me write the integration first, dz z square plus 2, and there is also the substitutions, which are this z, and there is also tan x equals to u. So by integrating, we will get y equals to 1 by root 2 tan inverse z by root 2. We are using this formula, integration dx x square plus a square equals to 1 by a tan inverse x by a. So first, root 2 tan inverse. So first we need to convert this z to u. So it will give u minus 1 by u divided by root 2 plus c, and again u equals to tan x, it will give y equals to 1 by root 2 tan inverse tan x minus cot x divided by root 2 plus c. So this is the solution of the differential equation. Okay, so moving to this problem here, it is a quite easy problem. It is obvious. So let us now try to solve this. dy dx equals to minus 2y square. So we can take y square with dy and minus 2 with dx. So it will give dy divided by y square equals to minus 2 dx. So if we integrate these, we will obtain minus 1 by y equals to minus 2x plus c. So this value of c, so here we have obtained the one parameter family of solutions. In order to find out the particular solution, we need to use this condition, which is this y1 equals to 1. So this condition can be used. Here it is saying that at x equals to 1, y equals to 1. So if we use that condition, we will obtain a particular value of c. So from the one parameter family of curve, we can obtain a particular solution by using this condition here. So let us now do that here. So at it is x1, y1. So by putting these values in the above equation, we will obtain minus 1 equals to plus 2 plus c. Therefore, c equals to 1. So by putting the value of c, we will obtain 1 minus 1 by y equals to minus 2x plus 1. Therefore, we will have here 2x minus 1 and 1 by 2x minus 1. So this is the particular solution of the solution curve that passes through 1, 1 point. Okay, so we have the next question here, which is this equation. We need to find out the solution, and as there is no condition given, we will obtain only the one parameter family of curves. So by separating, we can see that dy divided by 1 plus y square plus e power x dx 1 plus e power 2x. So we can solve it by the previous formula, which is x1 by x square plus a square formula. But we need to use substitution here, as the derivative of e power x is e power x and that derivative is present with dx. So for the second derivative, it is equals to 0. So for the second derivative, second part, we can use this substitution equals to z. It will give e power x dx equals to dz. Therefore, we have 1 plus y square plus, so e power x dx means dz, and below we have z square equals to 0. So obviously we can integrate and it will give tan inverse y plus tan inverse z equals to c. So this is the solution. Okay, so for this problem, again we need to separate the variables. It will give cos y dy equals to, so here x e power x log x plus e power x divided by x dx. So integration of cos y is very easy to find out, but we need to reduce this part. It will give e power x log x plus 1 divided by x dx. So cos y dy, here we have e power x log x 1 plus x dx. Okay, so there is a form like this which, okay, let me erase it. So the form says, suppose we have e power x, a function fx plus f dash x, then we need to substitute the e power x fx part. So as we can see, the derivative of log x, which is 1 by x, is present here. Therefore, we need to substitute e power x log x. So if we substitute e power x log x by z, we will get derivative of e power x is e power x and log x will be same. And after that, we can keep e power x and take the derivative of log x, and there is dx. So therefore, we have e power x log x plus 1 by x, this equals to dz. So we have cos y dy here, and this term we can see, and there is a dx here. So this term, this e power x log x 1 by x, this equals to dz, and z is e power x log x. So we can integrate cos y dy and integration dz, and there is also integration here, and z equals to e power x log x. So integration of cos y is sin y, and integration of dz is z plus c. So it will give sin y equals to e power x log x plus c. This is the solution. Okay, so moving to this problem here. So there is a term with xy, there is a x term, there is an y term. So we need to separate this at first. So what we can do, we can write it like this: 1 plus x square plus y square, 1 plus y square plus xy dy by dx equals to 0. It will give, if we take, sorry, there it should be, let me erase it. So it should be x square. So if we take x square common out, it will give 1 plus x square, 1 plus y square, and there is x, y, dy, dx equals to 0. Okay, so now we can separate the variables x and y. We can take 1 plus x square with this x and dx, and we can take this root over 1 plus y square with y dy. So we are going to do that. Therefore, it will give root over 1 plus x square divided by x dx plus y dy divided by root over 1 plus y square. equals to 0. Okay, now see that the derivative of y square has a y term, and similarly derivative of x square has an x term. So here there is a y, but there is no x here. So if we take a x and x here, it will make this x square. So we are going to do that. Therefore, we have root over 1 plus x square divided by x square dx plus y dy, and there is x 1 plus y square equals to 0. So next we are going to take the substitution. Substitution will give 1 plus x squared equals to, and also there is a root, so therefore we can take square here. So it will give 2x dx equals to 2y dy, and we can cancel out those two, which will give x dx equals to u du. And in a similar manner, 1 plus y square, we can take this as v square. It will give y dy equals to v dv, and it will cancel out the 2 here. If we cancel out the 2 here, so here we have obtained u divided by, so x dx means u du, and in the denominator we have x square. So from 1 plus x square equals to u square, we can write this x square equals to u square minus 1. So here we have u square minus 1. As for the second part, we have y dy means v dv divided by 1 plus y square means v square, and root, there is a root, so it will be, so the integration will take this form, u square minus 1 du plus d. Let me write it again. So we have u square minus 1 du plus dv equals to 0, where u is root over 1 plus x square and v is root over 1 plus y square. Okay, so here we can do this, u square minus 1 plus 1, u square minus 1 du, and there is dv. So if we separate these from here, if we take u square minus 1 separately and 1 separately, we will get u square minus 1 du. These two will get cancelled out, and we have here du divided by u square minus 1. I'm also taking the integration in this line, so dv equals to 0. So we have here u, integration of du is u, and this term, the integration of this term will give log of u minus 1 u plus 1 plus v equals to 0. So let me write the integration formula here. The integration formula in this case, du u square minus a square, it gives 1 by 2a log mod u minus a divided by u plus a. And there is also c, the constant of integration. So it will give root over 1 plus x square plus half log mod root over 1 plus x square minus 1 divided by root over 1 plus x square plus 1 plus v means root over 1 plus y square equals to c. Okay, so moving to question number 8. We have this system here. We need to find out the solution again. So here the separation of variable is quite easy. So we can write sin y plus y cos y equals to 2x plus 2x log x and there is also, sorry, there is a dy here equals to, there is a dx here. So if we take the integration, sin y plus integration y cos y dy equals to, so let me write it here, x square by 2. So integration of 2x, integration of x is x square by 2 and there is another 2. So it will get cancelled out and there is 2x log x dx. Now this integration here, let me first do it. Suppose I write it as I1. So let me first do the I1. I1, if we integrate this part first, y cos y plus integration sin y. And there is a dy here and a dy there. So there is a multiplication of two functions. Therefore, we need to use the multiplication formula. So in the multiplication formula, what we can do? We can take, we can take this as the first function and this as the second function. So by integrating by parts, what is the by parts formula? By parts formula is this, u into v, it will give u integration v minus integration derivative of u, integration of v and whole integration of these two terms. So we can do here y integration cos y dy minus integration of, and there is derivative of y is 1 and the integration of cos y is sin y. And we can see that there is also another sin y here. If we cancel these two, it will give y integration cos y. So y integration cos y will give y sin y. So from this side we are getting y sin y and there is x square 2 integration x log x. So y sin y equals to x square plus 2x log x. Again we need to use the integration by parts in this case. It will give, so we can take this as function 2 and this as function 1. We are taking log as function 1 as We do not know the integration of log, but we know the integration of x. So here we have x square plus 2 integration x log x. It will give x square 2. So this is log x. The log x will be out of this integration. And if we integrate this x, it will give x square by 2 minus the derivative of log x is 1 by x, and the integration of x is x square by 2, and there is dx. So it will get cancelled out. Therefore, we have x square plus 2 will get cancelled out. X square log x minus, here also 2 and 2 will get cancelled out, and we have integration x dx, which will give x square by 2 plus c. So we have x square by 2 plus x square log x plus c. So y equals to 1 equals to 0. It will give sine 0 is 0. Therefore 0. X equals to 1 half, and log x 1 means 0 plus c. So c equals to minus half. So by putting the value of c, we obtain the solution of this differential equation: x square plus 2 x square log x minus half. Okay, so find the solution. Okay, so there is a mistake. Solution curve, this should be solution. Find the solution curve passing through 0, 0, and the differential equation is this: dy dx e power x sin x. Okay, so we need to find out the integration of e power x sin x. So there is a formula. We can use that formula. So let me write the formula here. E power ax sin bx integration, it gives e power ax a square plus b square a sin bx minus b cos dx. So here we have gy equals to integration e power x sin x dx. So by using that formula, we can get a is 1 here and b is also 1 here. So it will give 2, and again sin x minus cos x plus c y, and there is integration sign here also. So it passes through 0, 0. So x equals to 0 means y equals to 0. It gives 1 by 2, and obviously this is 0. Cos is 1. So we have c equals to half. So by putting the value of c in the above equation, we can obtain this solution: sin x minus cos x plus half. Now moving to the last question, we have this equation here. Again, we need to find out the solution. Obviously, it can be separated, where one part has y terms and the next part has x terms. It gives this. So here we can do y plus 2 minus 2 y plus 2 dy, and here we can do this dx. Now if we separate separate this term from y plus 2. We take one term as y plus 2, it will get cancelled out with y plus 2 and another term will become 2 by y plus 2. So we are going to do that. It gives integration dy minus 2 dy y plus 2. There is integration dx plus 2 integration dx by x. So it can be integrated easily. There is y, there is minus 2 log mod y plus 2, there is a x, there is 2 log x plus c. So we need to find out the value of c by using x equals to 1, y equals to minus 1. So y equals to minus 1, there is minus 2 log 1, which will give 0. There is x1 and again 0. So we have c here. So c, the value of c is minus 2. So we can simplify it as y minus x, and as c is minus 2, if we take c to the left hand side, it will give plus 2, and there is 2 log x plus 2 log y plus 2, which can be multiplied like this, as log has a property that log a plus log b equals to log of ab. So this is the solution of this differential equation which passes through the point 1 minus 1. So in the upcoming videos, I will use another methods to solve the differential equations, like what we will do when we have a homogeneous differential equation or a linear differential equation, and so on. Thank you for watching. Please share, like, comment and subscribe to this channel. Thank you.